So without further ado, this is what I'll be covering today. So I'll be giving a short little introduction. Maybe we'll take about another 5 minutes of me just talking a little bit, and then we'll kickstart the revision session. And then at the very end, I do have some little matters to share with everyone. So for example, some of my group classes details, and also there will be a little giveaway at the very end. So do stay for that if you're actually looking for, if you want to win like a copy of the curated notes, okay, and maybe you can get a copy of the notes for free if you participate in this little giveaway at the very end of the session. So some of the things that I'll be mentioning today will be pretty important for the session at the very end. So please stay for it if you guys are interested in that. Okay, so I hope my slides are cute enough for everyone. Okay, so this is the introduction. So I'm going to first introduce myself in case this is the first time you're actually hearing me, and this is the first time you're actually listening to my class. For my own students, if you're here, welcome. Welcome to join us. Okay, and then for those that haven't seen me and this is the very first time, okay, I wish you a warm welcome, and I really do hope that you learned something from me today and you do benefit from this session. Okay, so first and foremost, let me introduce myself. So my name is Kaiwen, and I'm OVERMUGGED's O-level A Math and E Math tutor, and also I'm actually teaching H2 Math next year, A levels. So this is my scope. I mainly teach mathematics for OVERMUGGED. And I've been teaching for about 5 years. Actually, this is my second year with OVERMUGGED. So I teach at the site after my national service. So yeah, I love teaching, and this is what I'm actually very, very passionate about. And currently right now, I do have group students. So I have about 30 plus to 40 plus students. Majority of them are Sec 4s. I only take Sec 3, Sec 4s at the moment. And I'm actually looking to expand to next year. So looking for more students for next year to guide you guys through towards your O-levels or N-levels. So I do teach crash courses as well for OVERMUGGED. And currently from last year and this year, I've taught about 100 plus, 150 plus for both subjects. I think that's a pretty large number of people, okay, that have gone under my wing, and I really do. And from feedback, I know that these people actually did benefit from the sessions that I've conducted. So this is my picture. If let's say you cannot see my beautiful face, my face is here, okay, and that is my picture. So this is the subjects that I teach, which is basically every single math starting from Sec 3 onwards, all the way up until you don't ever take math again. And currently right now, what am I doing? So I'm a little bit different from the other tutors. I'm actually still an undergrad. So I'm still studying in university, and this is my 4th year in uni. So I'm currently in my hostel right now, and yeah, I'm in NTU. So yeah, in the corner west side of Singapore. And I'm studying mathematics. So I'm one of the weird people that love math a lot. That's why I choose to take math in university. And I'm studying pure math. So that is a branch of mathematics that deal with a lot of theory, a lot of proving as to why things are going on. And the things that I love to study, and like some of the modules that I really, really love, is all those geometry stuff. And those geometry that deal with like differentiation, deal with like your integration, those are little things that are the things that I really, really love. And I love to study those kind of stuff. Okay, so I'm kind of a math geek, one of the weird people that actually love the subject a lot. Okay, so I do know what I'm saying. So I do hope you guys benefit from whatever I'm about to share. So just to share with you some of my track records and my testimonials from my students. So I'm going to leave this on here for a short while I just rant on a little bit. So currently right now, I've been teaching for about 5 years, including this year. So for the past 5 years, about all my students, 95% got A's and B's for their O's and N levels, which is pretty impressive, I would say, on the students' part, not on my part, on the students' part, for actually being able to get those kind of grades. And I do have some improvements here that I want to just shout out. I will not say the name of the students, but these are some of the more notable achievements. So I do have students that started with me like in August. Okay, they came to me, then scoring F9 very, very badly for O-level E-Math. And then within 2 months, they jumped to an A2 for prelims. So these kind are the very exceptional kind of people that work really, really hard. Okay, so I do want to give them a little shout out. Okay, then I got students that start off with F9 and then suddenly jump to A1 for O's. Okay, so those are the kind of students that I have. Okay, and I do hope that I'm able to help you guys as well in this case. So these are just some of my students and some of the testimonials as well. And also another page here. Okay, so a little bit lengthy. So yeah. all of my students, I would say, I've taught about 100 plus for the 5 years really. I would say literally every single person got the desired grade that they want. So for example, I have students that are just aiming for, maybe for AMF, aiming for a B4, that kind of thing. And the person really did get like a B3 or even an A2. So that is really very impressive for someone that started off really hating the subject so much, but in the end, really did do well for the exams. Okay, so yeah, this is just some of my testimonials from my students. Okay, so I just wanted to share it with everyone. So last but not least, I did mention this just now. So I'll be hosting a little giveaway at the very, very end of the session. Now, this giveaway is going to be a little bit different from the other subjects. So all the other subjects are doing Kahoot, right? But for me, I'm not doing Kahoot, okay, because number one, no offense to people that love Kahoot, but I hate Kahoot. Okay, I don't like the platform. Okay, I hate the don't. I hate the music. Okay, that's not my thing. Okay, so I've come up with another way to do it, which is very, very simple. I hope you guys will participate in this. Basically, what I will do is I'm going to flash a question on the screen. One question. Okay, so just pop one question onto the screen, and whoever can give me the answer first, you'll win the notes. Okay, well, of course, the question won't be so simple lah. Okay, it will be definitely doable within the syllabus, but do need a little bit of effort. So yeah, later you guys will see the question. Okay, and that will be pretty fun. I hope it'll be pretty fun for everyone to participate in. Okay, so this is the overview of the syllabus. So this is the entire syllabus that we'll be studying. So I'm going to assume for today that the majority of people here are all Sec 3s and maybe like a few Sec 4s. So for my Sec 4s, you guys already have gone through everything and you guys already know like what are the more difficult topics. So for the Sec 3s, you're still dipping your toes into the EMF syllabus. Okay, maybe about half of your body is already in, and you kind of know which are the more scary topics for the syllabus. Later, I'll be sharing what they are. Now, for today, my main focus is actually to touch on the geometry and measurement section, so which is these 5 topics down here, excluding Pythagoras theorem. So I'll be covering in great detail of these 5 topics. I will not be touching anything else due to time constraint. Okay, I planned it in a way where I have just nice enough time for 5 topics, and I know that I'll be able to benefit these 5 topics with whatever I'm going to share today. Now, in the event, let's say you do want other topics today, there will be a Q&A session at the very end. So you do need to wait a little while, then I can answer some questions. So you do need to wait a short, like after the whole session, then please, you can ask your questions. Okay. So topics to focus on. So if you're currently in Sec 3 right now, and you do not know, let's say, for example, if your math, you're scoring like maybe a B4, B3, and you don't really know like what to focus on, these are my suggestions. So number one, do focus on your algebra, as algebra is a very, it's a very heavy topic, especially if you take AMF. Okay, you do know that the algebra in AMF is a little bit computational heavy, as of course the other topics here as well in EMF. Okay, and these 4 topics, just nice, we'll be covering them today. Okay, these 4 topics are also known to be some of the more difficult topics for EMF, and these are the topics that some students actually do struggle right now, even if they're in Sec 4. So that's why I do reach out to my Sec 4s and ask them to actually participate in this session as well. Hope that they can benefit from this. And for the very last one, if you're a Sec 4 student, you have already touched this topic called vectors in 2 dimensions. You already know the difficulty of this topic. For my Sec 3s, this is the very, very last topic that you will be touching before you head on forwards towards your mid-years, prelims and O's, which is vectors. Now, this topic on vectors is not the easiest thing in the world, but is doable. So unfortunately, I will not be able to do it today. So if you're interested in learning vectors, you can look for me separately. And also, vectors would continue on if, let's say, you're moving on into A levels. This topic will expand into an even scarier monster. I like to describe vectors as like a level 3 level kind of thing. So for those people that like to play games, right? Those kind of monsters that you see like level 1, level 2, level 3. Currently, right now, whatever you're studying in O levels is level 1. Okay, pretty harmless. Within like 5 strokes, you'll be able to whack that thingy. Okay, but when you hit into A's, that's when things start to get a little bit tougher. You do need to like go and get your better gear, get better sword, don't know what lah. Okay, then after that, you can fight the vector topic. Okay, then after that, if let's say you were to move on even further, okay, if let's say you are as crazy as me, you're going to take mathematics in uni, or you're going to take physics in uni, okay, you will see vectors even further, okay, in n dimensions, or even right even further. If anyone is interested, you can look for me. I can send you my university notes, and you can see what kind of monsters there are out there. Yes, I think someone pointed out vectors in 3 dimensions. Okay, is it like physics, vectors, and scalar? Unfortunately, no. So physics, the vectors that they teach you is just the vector triangle. The vectors in math is a little bit harder, so it's not that simple. Okay. So this is the structure of my revision session. So I'll be summarizing all of the key concepts. Okay, I'll guide you through some of the thinking processes that I have while doing questions. I will identify to you common mistakes and also some misconceptions. There are many in these 5 topics, so I feel that these are things that I need to stress in case some schools do not stress it to you. I will also share some of the question variants. Okay, I'll describe how I'm going to do that in a while. And also I have a little bit of some worked examples like cluttered around, not a lot, okay, but a few. Okay, and I'll use them to actually go through some of the concepts that I'm interested in. Okay. So without further ado, okay, this is the second time the link is being shown here. So if anyone is still coming in, okay, you need the link is here. Or if anyone is going to actually ask for the link in the chat, can someone just help me to post the link one more time? Okay, thank you very much. And let's officially begin with this whole entire revision session. Okay, so let me take a sip of water as I'm talking quite a lot. Okay, hang on. Okay, so this revision package in front of you. Now, the first 3 pages are some promotional materials. We'll be talking about those later at the end of the session during the housekeeping session. So I'll just like to bring our attention to this page here. So this is the official first page. So if you were to go and attend my other sessions, as I'm also hosting the A Math session tomorrow and the H2 Math session next week, every cover page will be a little bit different. Okay, for the E Math one is a donut. In mathematics terms, we call it a torus. For the A Math is actually another figure. We call it a Klein bottle. And also for H2 Math is another kind of figure. We call it some spiral. I forgot the name of it. Okay, so this is how I identify my notes for everyone. Okay, is there any way to increase the presentation resolution? I don't think so. Is it really very bad? Okay. I'm going to zoom in now, so I hope that will help. But this is the best that I can do. Yeah, because I don't really know how. I'm a bit of a boomer. I don't really know how to tweak. Yeah. Oh, it's a bit blurry. I see. Sorry, I don't really know how to. Okay, Okay, I don't think I can do anything about it at the moment. Okay, but I will zoom in. Okay, and I believe everyone has a copy of the material, so I think it should be okay. I do apologize if it's a little bit blurry at the moment. Okay. Okay, I'll zoom in, so don't need to worry. Okay, so let's begin. So this set of notes, second page here is just some information about myself. Okay, these are some of the details and what these notes are going to do. Now, this thing here. So this is a database of resources. So a benefit of joining this session today is you get access to all of this stuff here. So currently in the moment, I'm actually working on more of the chapter summaries. So those free notes, unfortunately, my time is a little bit packed at the moment. So that's why not a lot is out there. Okay, but I'm trying my very, very best to churn everything out as fast as I can. Okay, and also my monthly practice series. I believe most people should know about this. It stopped at July, or I think, yeah, July, because I don't have enough time to complete the rest. Okay, but I believe there are at least 3 months worth of questions and solutions there. And I'll be also updating as the months go on when you move on to Sec 4 next year as well. Okay, and last one is the solutions to the curated questions in this revision package. So inside this package here, there are questions that I found. Now, these questions here are actually very different from those that are actually in the monthly series. So I don't think there should be any duplicates because when I calculated my questions, it's all kind of different. Okay, so the questions inside here are on the more difficult scale. These are the kind of questions that I give to my own personal students. Okay, so what I pride on is I like to torture my students. Okay, I love to give them slightly more difficult things, and I have a methodology why. This one I will share at the very end. Okay. So this QR code, everyone has access to it. So anyone you need materials, you can just go there and search for. Okay. So this is the content page of all of the geometry chapters that I'll be covering. Now, of course, within this whole list, there are missing chapters. Now, these chapters are not covered because either they are taught in Sec 4 or because they are taught in lower Sec. So I never put in the angle, triangle, polygon chapter. And I also didn't put in the vector topic. Everything else is here. Of course, Pythagoras theorem is just the formula, so there's nothing much to say. Okay, but these are the main things that I want to share. So yeah, let's go through each and every one. Now, I believe if you are viewing this folder or this PDF on a computer or whatsoever, I believe all of these things are hyperlinked. So you can actually just click and you will be able to jump between the different sections during your revision. Okay. So let's go into the sections and let's begin officially. Okay, enough of me talking so much. Let's begin officially. So we're going to talk about congruency and similarity. So first thing I want to say is this. Now, everyone here, if you're in Sec 3, this topic down here will be a little bit different as compared to the previous years, as this is the first batch of the 4052 syllabus. So if you're Sec 4 this year, this topic will be a little bit different for you guys. Okay, Sec 3, this is, of course, whatever you are learning. If your teachers have never mentioned anything about a syllabus change, means they never tell you. Okay, but the only difference here, okay, let me just, sorry, my pen just died. Oh dear. Oh dear. Oh, okay, thank God. Okay, so the only difference here is this portion here. So this is the additional information, which is the properties and constructions of perpendicular bisectors. This used to be in the angle, triangle, polygon chapter, but now it is inside congruency similarity. So this is the main difference. Everything else is identical. So let's begin this chapter, and I'm going to go through all of the congruency tests and similarity tests. So this is a list of all of the different kind of congruency tests that we have. Okay, namely triple S, SAS, ASA, and also RHS. Okay, so these are the types of congruency tests that you need to memorize for your exams. Now, these tests are not provided. Okay, like there's no formula list or anything. This is a memory work thing. So please go and memorize that you need to prove all of these different things right here. Okay, so I repeat again, triple S, SAS, ASA, RHS. These are the four. Now, the one that I want to focus on will be SAS. Okay, the reason is because now a lot of people didn't know this fact, is that the angle chosen must be the included angle in between the two sides. Now, there's a very long reason as to why this is the case, but the reason is not in your syllabus, so you don't need to know the fact. But just remember this case that you need to know that the angle must be in between. Okay, so when you're proving your SAS test, you do need to make sure the angle you choose is definitely in between the two sides that you choose. Okay. Next, we're going to touch on the similarity test. Now, similarity tests, there are three. Okay, and some schools, they teach it in a slightly different way. So I have a way of teaching it, and of course, the different schools have a different way of teaching. So these are the three tests, triple A, corresponding side, same ratio. And last one is two ratios of the same side plus one included angle. Now, some schools, they call the second one SSS. Oh, sorry, my pen is too thick. SSS. And some schools call the last one SAS. Now, personally, for me, okay, I don't like to use the words SSS and SAS. Very simple reason is because I don't want to confuse myself between congruency tests and similarity tests. Now, for what I have actually known, okay, for the past few years of studying like this topic and everything, most of your proving questions are always triple A or double A. So you just actually need to know this one, and it should be pretty safe and you should be pretty safe for all similarity test questions. Now, someone asked in the chat recently, okay, why is it that I put triple A and not double A? Okay, simple reason. Now, of course, we all know that double A is enough. The reason is triple A is because it is more complete. It is more accurate to say triple A than double A. So in actual fact, okay, thank you for the question, for whoever asked it. You can actually just prove two A's because automatically the last angle will be equal. Okay, it's a very logical thing. So if two of your angles within the figure is the same, obviously the last one will be also the same. Now, one very, very common mistake that many students make when they're doing this particular chapter is thinking that triple A is a similarity test. And this is not true. I have a very simple way to explain this. Okay, a very simple way to analyze and visualize this. Okay, watch. So this is an equilateral triangle. Okay, so let me write now. Oh my God, I just butchered the spelling for equilateral. Sorry. How do you spell equilateral? E-Q-U-I-L-A-T-E-R-E-L. Apologies. Okay, so this is an equilateral triangle, and we all know that the angles in an equilateral triangle is 60 degrees. Okay, so I'm just going to label one of them 60. Now, I'm going to draw another one. So here, this is another equilateral triangle. So obviously, my drawing is not very accurate. Okay, like that. And I'm going to claim that this is 60 as well. So if you tell me that triple A or double A is a congruency test, means you're telling me that these two triangles here are the same. Is that true? Obviously not. Okay, it is ridiculous. So you just need to remember this very, very simple example, okay, that equilateral triangles, different sizes, okay, all the angles are going to be the same, but they are 100% not congruent. Okay, so triple A is a similarity test, not a congruency test. Next, let's move on. So this page here, this one, proof writing. This page here is very, very important. So I just taught my student this morning, okay, I told her the same thing. This particular page, page 9, if you're able to print out, okay, you burn the paper and you drink before your exam. Okay, I can tell you this page is one of the most important pages in this whole entire topic. Why? Because this topic here will tell you the different ways of writing your proof statements. And proofs are things that a lot of students cannot write, even in like when you go further. Okay, because when you want to prove something, there is a certain process that you need to actually do it. Okay, so let's talk about some of the important things that we need to remember when we are proving. So first concept, the naming convention. So what do I mean by naming convention? Is that your whole entire triangle, whenever you are going around the figure or you are naming your figure or whatsoever, you need to make sure that the figure is going in the same direction. So this means what? If everything is clockwise, everything has to be clockwise. If everything is anti-clockwise, everything has to be anti-clockwise. So you need to be very careful whenever you are doing questions like this. So a little advice that I give students for this particular concept here is that we always draw out the triangle. So for example, if you're given a question that says prove that this triangle is congruent to this triangle, what I will do personally is to draw out the shapes. So I will draw on my figure two little triangles like this. I'll label, for example, A, B, C, X, Y, and Z. Okay, for example, these are the equal angles, for example. Okay, and these two are equal, and this length is equal. Okay, so for example, if I'm going to use the SAS or ASA test, sorry, what I'm going to do is that I'm going to draw out these triangles first, and then now I'm very, very sure which angles are equal. And I never will ever make mistakes whenever I'm labeling my angles. So for example, angle ACB is equals to angle XZY. And when I write it like that, right, it automatically becomes correct because everything is moving in the same direction. Same thing for your length. For example, AC equals to XZ. Everything is in the same direction. Anytime you go and write AC equals to ZX, that is wrong. Okay, because everything must form in the same direction. So this is very important. Okay, please remember this concept here. Next one is the types of justifications. So like any angle topic that you cover, okay, be it the first chapter or the upcoming chapter, whenever you do anything that deals with an angle or anything that proves, okay, you need to write a reason why. Okay, so please explain the reason why something works. Okay, so there are three different types of justifications that we need to give. Okay, let's talk about the different three. The very first one is something that I call given. Now, this word given is a very important word. Okay, I'm going to define the word given in English. I'm not an English teacher, okay, but when something is given to me, it means that it is provided to me. Means the question says so. Okay, if the question never say, you cannot say given. The question must literally say angle ABC is equals to 90 degrees. Then I can write in my question and say angle ABC is 90 given. But if let's say you have done some calculation somewhere, or you go and observe there's an alternate angle, or you see something, that is not given in the question, you cannot say given because it is not given to you. You have used your power of observation. Therefore, you can get the value. So for those kind of cases, you need to explain how you got it. So a little advice that I give students for this topic is you need to be kiasu. Okay, so Singaporean term, we need to be kiasu when we are doing this topic. Explain everything. It's better to be kiasu than to forget things later and get the question wrong. Okay. Second one, common length for common angle. So for example, if one of your angles is repeated, or if you have a triangle and your lengths are shared, one way that I write is this particular length is a common side, or this particular angle is a common angle. So from this process here, it automatically tells examiners that, okay, this is your A or your S that you're going to use. There's another way of writing, of course. You can also just say this angle is equals to this angle, and therefore they are the same angle. Also can, no problem. Okay, either one works, but for me, I think it's easier to just say this is a common angle. Okay, this is for me. And the last one is the calculated things. So for example, if you have calculated something, or let's say if you have shown, or you take like 180 minus 90, that kind of thing, and you say that this is 90, right? You need to explain why. You need to explain why it is 90 degrees. Okay, you need to tell people, because supplementary or because complementary. Okay, all these things you need to know. Please go and memorize the list of all of the angle properties. There are so many out there. Okay, like complementary, alternate, interior, corresponding, Okay, so just remember to calculate. Okay, I'm going to answer some questions. So one of them is, when you're using the SSS test, how do you ensure that the namings are correct? So SSS means there are congruency, right? Okay, and whenever you are labeling your triangle, okay, like for example, okay, if you have a triangle that looks like this and a triangle that looks like this, okay, you need this to be 3, 4, 5. Oops, sorry, 3, 4, 5. So as long as you can match up the triangles like this, right, then you know that you're in the correct orientation already. Okay, because like your 3 must be to the next of the 4 is the kind. Okay, so it's those kind of examples lah. Okay. Next one, why is calculated angles and not calculated angles and lengths? Because very simple. When was the last time have you ever seen a question that requires you to calculate length during the proof? Don't have. Very rare. So that's why for me, I just write angle. Okay. Last one, give an example of a common angle. Sure. Okay, simple example. Triangle. 90 degree. 90 degree. Okay, so the question is, for example, A, B, C, D. And the question asks you to prove that triangles ABC is similar to triangle DBC. Okay, sorry, DAC, my bad. So the common angle. Yeah. So this is just a very quick example as to what a common angle is like. Okay, so it's because someone asked the question. So just to say something, for those that have been asking questions, right? Thank you for the questions. I will definitely answer your questions. But if possible, right, please give the question to everyone so everyone can see. So that it doesn't look like I'm just answering nothing for the rest. Okay, thank you. Yep. So this is just basically everything I've said. Okay, this page is super important. So please remember that. Okay. Now, we're going to talk about this next concept here, which is the additional thing in this particular topic, which is the perpendicular bisectors and the angle bisectors. So for the very first one, let's talk about the angle bisector. So what's the definition of an angle bisector? An angle bisector is a line that will cut your angle in half. Okay, very important. A line that divides an angle into two congruent angles. What does it mean, congruent angles? Equal angle. So for example, if this is 60 degrees, example, when you chop this angle in half, this should be 30, and this should be 30. So you guys need to know how to draw, okay? Need to draw the angle bisector, and let's go and talk about how to draw. So there are a few different steps that you need to take. Now, number one, first thing when you get the angle that you need, okay, we are going to open the compass jaw. So I'm going to do some hand signals here. Okay, so you're going to open your compass jaw, okay, like my thumb thingy and pinky here. Okay, when you open your jaw, okay, you need to make sure that the length of the open jaw is more than half of the shorter side. Okay, so when you do that, after that, you mark out on your A and your B arcs down there. Next step, what you do, now you move the compass, but you do not close the jaw. I repeat again, you do not close the jaw, okay? And you go and put your pointer thingy at A and B respectively. And then you're going to mark another arc and make a cross out there at C. After that, connect C and Y together, and therefore you can get this whole entire shape. Okay, and then after that, the angle ZYC will be equals to CYX. Okay, so this is very important. This is how you draw an angle bisector. Okay, repeat the steps one more time, sure. First thing to do is to open up your jaw. Okay, when you open your jaw, it must be more than half of the shorter length. Okay, I repeat again, it must be more than half of the shorter length. Okay, next, when you mark out your A and your B, next, you take your compass, okay, you put your pointer on A and B respectively. After that, you mark on the inside of the triangle or whatsoever, okay, and then you just put it down there. Then after that, you connect C and Y together, and that will be your angle bisector. Okay. Okay, so this concept of an incircle down here, okay, just take note that incircle just means that we can actually inscribe a circle within a triangle, and the method to do it is using angle bisectors. Now, this concept down here, even though it's not entirely in the syllabus, I have seen schools that test this concept before, so that's why I decided to put it in. Okay. Next, I'm going to talk about the perpendicular bisectors. So perpendicular bisector is the same concept. Okay, now perpendicular bisectors means what? Now a perpendicular bisector is going to be a line that is obviously perpendicular, or obviously, I hope it's obvious, perpendicular bisector. Okay, and this line must cut your whatever line in half. I'll repeat again, in half. Okay, and this is why for my AMF students, when you calculate perpendicular bisector, you find midpoint. Dun, dun, dun. Okay, so everything is connected in life. Okay, so remember, for perpendicular bisectors, we always cut our line in half. So that's why for my AMF students, when you calculate your perpendicular bisector equations, why? What's the first thing we find? Midpoint. This is the reason. Because you chop the line exactly in half. And what are the steps to take? Okay, I'm going to repeat these steps. So listen carefully. Step 1, you open your compass jaw. Okay, and it must be more than half of the length of the line. So for example, if the length says 7, you open your jaw to 4, 5. Okay, agar-agar around there. Next, you're going to take your pointer, your pinky pointer. Okay, you're going to mark 1 at Y, and you're going to mark a little cross up there on top of the line and below the line. And then you repeat the same process at X until you form 2 crosses. After that, join. Okay, this is how you draw your perpendicular bisectors. Now, some people will ask me, oh my God, what happens if I draw inaccurately? How to check? Okay, there's a way to check. So fun fact, there is actually a way to check whether have you drawn it accurately or not. Let me share with you. So for angle bisectors, what is the way to check? Very simple. Measure your 2 angles. So what I will do personally, take my protractor and go and measure angle ZYC and also angle CYX. And then if let's say both are aggregation equal, and then you save, confirm correct. For the other one, okay, how do you measure? You just draw all the way to the center, okay, and then you just measure the 2 lines. So I think I never write the coordinate here. Okay, let's maybe call it C. So XC must be equals to CY. And you know that very safe, confirm you have drawn your perpendicular bisectors accurately. Next thing I want to say is about this concept called a circumcircle. So circumcircle is another type of circle that you didn't know, didn't know, oh my God. Sorry, a circumcircle is basically when you have your perpendicular bisectors, okay, and what we're going to do is these 3 different perpendicular bisectors, they're going to intersect at a little point in the center, and we call this the circumcenter. And this circumcenter is going to be the center of your circle when you draw around your triangle. So take note, there's a difference. I'm going to change the pages a while. So perpendicular bisector, when you're drawing the circle around, is actually on the outside of the triangle. For angle bisector, it is on the inside of the triangle, and this is what we call an in-circle, in-center. I believe that these concepts here for in-circle and also circumcircle may not be in the syllabus, but the reason I'm sharing is because I have seen schools that set these kind of questions before. I can name the schools. For example, I've seen Dunman High questions before. Nanyang Girls High School, their set 1 drawing question got this concept. Okay, so that's why I put it in the notes. So I hope it's beneficial. Okay. Next, let's talk about this concept here of area and volume of similar figures and solids. So I'm going to share that this particular concept down here is very important. And I also know that this concept down here is something that a lot of students actually have issues with. So when we are looking at planar figures, now planar figures means 2-dimensional figures, and the question says that the figures are geometrically similar. I'm going to repeat that point again. The question must say that the triangle or whatever figure is geometrically similar. If the figures are geometrically similar, then we can use the formula A1 over A2 is equals to L1 over L2 square. I repeat again, the question must state that these planar figures are similar. The question will say geometrically similar. There is one concept out there. If you guys didn't know, I'm going to share with you a little secret. Okay, there is one type of shape that they will never say is geometrically similar, but it is, which is regular polygons. So I repeat again, regular polygons. Now, obviously, when I say regular polygons, I mean octagon with an octagon. If you're telling me that an octagon is geometrically similar to a pentagon, you have issues. Okay, that one is your problem, not mine. I'm telling you now that a pentagon, a regular pentagon, is geometrically similar to another regular pentagon. And this is a fact that a lot of people didn't know. You can always use similar triangles. You can always use this formula whenever you need to solve those kind of pentagon kind of question. Okay. Next one is volume of solids. So for volume of solids, volume of solids, right? They are geometrically similar. This is the formula. V1 over V2 is equals to L1 over L2 cube. So we only use this kind of figures or this formula whenever we are talking about, I repeat again, I stress the point, geometrically similar figures. You cannot claim any Tom, Dick, and Harry figure is geometrically similar. Cannot. The question must say. And trust me, every question will say. Okay, let me recant whatever I said. Not all the time. Okay, there is one type of case where they will never say. And this is a little secret as well. When you are chopping your figure, chopping a shape. So let me explain this concept. Very simple. Now, you know, when you, for example, your parents, they drive on the road, right? Okay, and then you see those kind of the traffic cone. Okay. You take those kind of traffic cone and you chop in half. Okay, when I mean chop in half, not the planar way. For example, with the cone, sorry for the horrendous drawing. Okay, but like that. When you chop the cone like that, and of course the cut must be horizontal. It cannot be slanted. If it's slanted, obviously it's not similar. Now, whenever you see questions that you chop the figure, the top cone and the big fat cone are geometrically similar. Questions will never tell you one. This is a case where you need to know. Okay, so I warn you again, whenever you see figures that have chopping, geometrically similar. Okay. Wait. Okay, so basically we're done. Okay, that's the end of the topic. So I believe I have posted one question. I don't know whether, okay, this one. This one. So this is an example of a question where you have the chopping. Okay, so you need to know this part. The chopping question, this is how you solve this kind of question. Geometrical similarity. Okay. There are some example questions here, and these are the kind of questions that I set for my students. And I can promise you that these questions are difficult. So you can give them a try. The solutions for these questions will be uploaded 1 week later. I repeat again, the solutions for these questions will be uploaded 1 week later. Okay. So I'm done with this chapter. So what I'm going to do is I'm going to look at some of the questions that people have, and I'll answer those that are good. Okay, wait. Okay, send notes. Is it the only part that's new in the new syllabus? Yes. Okay, thank you. Someone asked, when they see a larger volume of the same bottle, is it geometrically similar? Answer is yes, because they say it's the same bottle. I think the question phrasing is a little bit bad. The question should say that the geometrically similar bottle, then it should be the same. But this one just need to be a little bit careful. Yeah, for the question that someone asked about the same bottle. Wait. Can you explain how chop figures are geometrically similar? Okay. Sure. If you cannot imagine, right? How to explain this? Okay. If you cannot imagine, you literally go and try it yourself. It's going to be geometrically similar. It's a guaranteed thing, one. Yeah, it's just a concept. A little bit hard to explain now, but you can go and try. You go and take downstairs your house the traffic cone and go and cut, and then go and see. It's confirmed geometrically similar one. Okay. I see questions about density and mass. So for density and mass, it's always using the volume formula. This one. Okay. Okay. Yes. The question asks, a lot of people are asking, right? Where is the solutions going to be uploaded? Okay. So if you recall the second page of the notes, right? There's a QR code. It's there. Okay. If you go and scan the QR code, you will see 3 folders. First folder is all the chapter summaries. The second folder is all the monthly questions. The third folder is the answer. Okay, and I repeat, the answers will be uploaded 1 week later. I repeat, 1 week later. Okay, the simple reason is because I have 4 subjects I need to write for. I don't have time. Okay, so I'm going to churn as fast as I can. Okay, I understand that everyone is gunning for exams, so I will do it to the fastest of my abilities. Okay. People are asking whether is it volume equals to mass. Answer is yes. Okay, so just take note of that. What do you mean by geometrically similar? It means that the figure is identical, like that kind of thing. Okay, so for example, 2 different shapes, right? There is like a shrunken version of the other. They are going to be identical. Okay, that is what it means by geometrically similar. It means that the different dimensions of the side, the ratios are all the same. Okay. Why is volume equals to mass? Formula. There's a certain formula that links volume to mass. Yeah. Okay, sorry, there's so many questions. I do need to move on. If they tell you the length of 2 cones and the volume of 1 cone, they ask you to find the volume of another cone. How do you find the volume of the other cone? Okay, so for your question, right, the person that asked about 2 lengths and given 2 lengths of a cone and the volume of 1 cone, asked you to find the volume of another cone, you just use the formula, fill up the values. So you got L1, you got L2, and you got the volume. You just manipulate to solve for the last V2. You will get your answer. Okay. Hi, what if they give cost? Okay, for cost, right, is surface area. So this one need to be a bit careful. So surface area is linking more towards the area formula. Yeah. Recording will be uploaded to OVERMUGGED channel. Yes, it will. I believe tomorrow. I'm not very sure when. I think it's tomorrow. Okay, last question, once I cannot continue. For shopping of a shape, if you cut a cone, wouldn't the tip will be gone already though? Okay, to whoever asked that, okay, the question very cute. So when I chop the figure, right, I'm talking about this part. It's geometrically similar to the whole thing. I'm not talking about the below part. It's not this. It's not the bottom. It's the baby cone, the baby this part is geometrically similar to the whole thing. That's what I mean. Okay, not the below. The below definitely not going to be. Okay, yeah, just take note of it. Nice question though. Bro, the top of the okay. Okay, let's move on. Okay, thank you for all the questions. So I will every topic I will try my best to go through questions. There are a lot of questions, and some are actually very, very good. If I really do run out of time, I will push the questions towards the very end. Okay. So let's move on. Okay, I hope I shared some secrets about this chapter, and I hope it's beneficial for everyone. Let's move on to my favorite topic of the syllabus, and I know everyone hates this topic, properties of circle. Okay, I love this topic to the core. I know of people that hate this topic to the core, and I always laugh at them. Why? Because this topic is so fun, in my personal opinion. So, properties of circle. Now, there's a list of circle properties that you need to memorize. And this whole entire set of notes here, the examples are all there, okay, for you to memorize. So I'm going to go through it very, very quickly. Okay, and I know some schools actually do not teach this topic, so I'm going to go a little bit faster for this, as I want to spend more time on Trigo. So let's talk about the symmetric properties first. So number one, for the very first symmetric property, we talk about the chord theorem. So if we have two chords and you need the definition of a chord, it's at the footnote down there. Okay, I'm prepared for everything. So the chords are equidistant from the center of the circle. Okay, so this is one property. Next, we talk about perpendicular bisector theorem. So the perpendicular bisector theorem, now in schools, I don't think they call it perpendicular bisector theorem. They just tell you the name of the property. So you just need to know what is it called. So if you were to claim it in exams, remember like what I said previously, all angles need to state. You need to state the reason why things are going on. Okay. So for example, remember the concepts of perpendicular bisectors? I've mentioned it just now. A perpendicular bisector cuts a line in half. Everything is connected. The whole syllabus is connected. So when you're doing this, AM equals to MB. So this is a very smart way to study math. I'm going to share with you guys. Now, when you study one concept is going to link to many things. So you don't need so much brain space for so many concepts. Like for example, once you finish perpendicular bisector, then you know that it cuts at the midpoint. Then you got two theorems down here done. You got your formula for perpendicular bisector done. So you don't need to memorize so many things. So partition your brain properly. Okay, it's like your graphic card, or don't know what is it called. Okay, I'm not going to embarrass myself with wrong words. Okay, so perpendicular bisector concept, AB perpendicular to OM. Next, every point on the perpendicular bisector of a line segment is equidistant from the center points of the segment. This is a very important property, and I believe a lot of people actually didn't know this fact. So this means what? I can draw this for any random old perpendicular bisector, like this. Oh, sorry, it's not. Like that. So if you were to start from the vertices, like this, and you were to draw a line from the vertices towards your perpendicular bisector, this line would 100% be equal. Okay, and it can be anywhere. Like for example, from here to here, these two will be equal. From here to here, these two will be equal. Yeah, all these will be equal. This is a very important concept, especially in this topic and your congruency similarity topic, if it comes out, and also the coordinate geometry chapter. Next, tangent theorem. So these are the concepts of tangents. So tangent is basically when you have a line that cuts like your curve or your circle at exactly one point. I repeat again now, one point. tangents are always perpendicular to your radius. So a tip, whenever you see the words tangent appear in your question, straight away go and draw your 90 degrees. But just a little warning, when you draw your 90 degrees, you need to make sure that it is to the center of the circle. Okay, the line down there, like OT, must be the radius of the circle. If the question never say that is the radius, it cannot be 90. It's not true. You need to make sure that it is the radius of the circle. Next, tangents drawn from an external point to a circle are equal. So this is an important property as well. So you have this shape down here. Two things are going to happen. AT is equals to BT. So as long as you have two tangent lines extending towards an external point, these two lines are going to be equal in length. A few more things, the angles are also going to be equal. And the ultimate fact is that these two triangles are congruent. And there's a very simple proof for it, RHS. So you can use RHS congruency test to prove that these two triangles are indeed congruent. I leave it to you to do on your own. It is very simple. Okay, to prove the right angle is literally just tangent perpendicular to radius. The hypotenuse is the same side. The side, you can just say that OA equals to OB, radius of the circle. Okay, so this is how you prove that these two triangles are indeed congruent. Next, we're going to go through the 4 angle properties down here. Number 1, angle property. Angle at center is 2 times the angle of the circumference. So this is the famous arrow shape that we all look out for. But I want to warn you, in case you did not know this, okay, this is a very important warning. This is a very important warning, is that this particular shape down here is not all the time going to be an arrow shape. There are other cases, and there are 4 listed down there. The one I want to stress is the last 2 here. For this particular one, let's talk about this one first. This particular shape is very common in your arc length area sector chapter, as you will always see right angled triangles within your circle. So you need to remember this fact. The angle at the center is the center is double the angle of the circumference. So this shape here is very, very popular in your angle arc length chapter. Now for this one down here, this is a very scary common mistake that many people make. People confuse this with the butterfly. So which is angles in the same segment. You cannot say that this is angles in the same segment. Very simple reason is because angles in the same segment condition is that all 4 vertices or all 4 of the corners of your butterfly must touch the circle. For this case and for this particular property, it must always be 3 sides. So 3 of the points will touch the circle, not 4. If it's 4, then it will be angles in same segment. But of course, the most common one is the arrow shape. So please remember the arrow shape. Okay. Someone asked, what does it mean by angle at the circumference? The angle is on the circumference. Okay. Next, angles in a semicircle. So this is a very important property as well, and it's used like literally everywhere. Okay, so when you have a triangle that is inscribed within your circle, and you have one of the line is the diameter. I say again, the line must be a diameter of the circle. Then okay, the angle will be right angle. Okay, you cannot be just anyhow say like, oh, a random triangle become 90 degrees. No, And one thing I want to say first, okay, which is very important. Whenever I teach my students, there's one phrase I hate the most, especially in this chapter. The phrase is, this angle looks like 90 degrees. Wow, cannot. Okay, this one cannot. You cannot anyhow say, oh, okay, this angle looks like 90 degrees, therefore it is 90 degrees. No, it doesn't work that way. You must show that it is 90 degrees. Okay, don't ever say that, oh, the line look parallel, so parallel. No, like that doesn't work. Okay, or else I say, I think I get 100, then I get 100. No, we got like that one. Cannot. You must show. Okay, must show that the angle is 90, or the angle is in, or the line is indeed a diameter. Okay. Next, butterfly. So this is the butterfly shape, but I want to say, I got one student. So sad. During prelims, go and, because forgot the name of the property, go and write butterfly for exam. Please, no, cannot. Okay, butterfly is a way to memorize. It's the same thing for the arrow. It's a way to memorize. It's not to write as a name of a property. Okay, please be careful. The property is called angles in the same segment. So we always look out for the butterfly, and you must remember the condition for the butterfly. All four corners of the butterfly must touch the circumference of the circle. It cannot be hanging anywhere in the middle or on the outside or what. It must be on the circle. Next one, cyclic quadrilateral. So this is the very last concept. So for a cyclic quadrilateral means a four-sided figure within a circle. If you have a four-sided figure within your circle, you need to remember that the opposite angles are supplementary. So they add up to 180. And a very common, not so common property is at the bottom there. Exterior angle is equal to interior opposite angle. So if you don't believe, you can go and try. You can try to go and explain and try to prove it to yourself why this is a fact. It's a very simple proof. Because you know that opposites are always adding up to 180. So you have your, when you extend one of your lines out, the exterior angle down there will definitely be inside. So if you cannot convince yourself why it is true, okay, it's very simple. This angle here is 180 degrees minus, for example, theta. This is theta. This will be theta. And that is about it. Okay, so that is the end for this chapter. So okay, because I'm running out of time, so questions, let's keep it to the very end. Okay, if anyone has any questions, you can just slowly just start putting in. I will try my best to scroll back and look for your question. Okay, if possible, right, like I said, if you can put as everyone can see message, so that if anyone can give the answer, you can feel free to give, but please make sure you give answer, you give correct answer. If you give wrong answer, I will come find you. Okay, don't anyhow teach people wrong thing. Okay, but please do try. Okay, it's a good learning experience as well. And we're done. So there are quite a few properties here. Okay, so please go and memorize your properties. This chapter is not a difficult chapter, so I hope you guys don't lose marks at this kind of chapters. Next, okay, dun. Scary chapter alert. Triple. So this chapter, I know a lot of people don't like. Okay, thank you for sharing the link again. Thank you. So I know a lot of people really do not like this chapter. Okay, but so sad. This chapter is not difficult in any means, not difficult at all. So how do you do this chapter? So there are a few concepts that you need to remember. And these notes actually summarize every single thing that you need to know. So we're going to go through them slowly. Okay, there are some things here that I'm going to share little tips and secrets that I actually use to teach this particular topic. So do listen for them very carefully. Okay, and if you need me to repeat, please do ask. I will definitely repeat. So after this topic, there'll be two more topics. The last one that I want to spend more time on would be coordinate geometry. So this one and also coordinate geom. These are the heavier ones. Okay, so let's kickstart into trigo. Let me get a sip of water first. Wait. Okay, trigo. So trigonometry. So the first thing, Tokaso. So someone just mentioned, very good, Tokaso. Your Tokaso also typed wrongly. Okay, so please remember, Tokaso, please be careful. Okay, Toachahosh. Okay, you bro, the one that just mentioned the Tokwasa, that one wrong, Okay, please is Tokaso. Toachahosh. Okay, so please be careful. Okay, so please remember, sine is opposite over hypotenuse, cosine is adjacent over hypotenuse, and tangent is opposite over adjacent. So just be careful. Okay, now just remember that Tokaso questions are always for right angle triangles, because I have students that go and try to use Tokaso on non-right angle triangles, and it's very sad. Please be careful. Tokaso only works for right angle triangles. Next concept, obtuse angles. So, the screen is blurry. Sorry about it. Okay, I'll try to zoom in as much as I can. I'm trying to fix this issue. I don't know what's the reason. Let me go and check on it. Sorry about it. Okay. Trigo ratios of obtuse angles. So for the obtuse angles, right, these are the three that you need to remember. okay, which is sine theta is equals to 180 minus theta. Cosine theta is equals to negative cosine 180 minus theta, and tangent is negative tangent 180 minus theta. For the tangent one is not really required in the syllabus, but there are schools that test this, so that's why I put it here. Okay, but the main two is definitely the first two. But there's a little fun fact for students that take both A math and E math. Okay, this particular concept here, actually, you can use something else to help you memorize. Okay, is that, for example, you know your ASTC properties, right? Your second quadrant, okay, is your S quadrant, and therefore sign is positive, the rest are negative. Okay. Next, we're going to go into the next few concepts, okay, which will be bearings. So the next concept will be important, that is bearings. So one of the things that I like to remind students for bearing questions is that all bearing questions are phrased in the same way. So if you're my normal student, you should have heard me saying this thing like literally every week. So bearing questions are always phrased in the same way. Of something, from something. I repeat it again. All bearing questions are always phrased in the same way. Of something, from something. To solve bearing questions, I have this step-by-step process here. So I'm going to share. Number one, we always start from the from, because that is your point of origin. At the point of origin, we're going to draw a north line. So I'm going to draw a very simple diagram here to help you visualize this process. So you have A here and, you have B here and you have A. So the question says you need to find the bearings of B from A. So the first thing I will do is to identify where am I starting from, which is from, like literally my sentence say from. So from the A, what we're going to do is to draw a line going up like this. And this line is going to be your north line. So for the north line, okay, what you're going to do next is you're going to connect this A and B points together. If the question is already drawn for you, then of course, good for you. But sometimes it is not, so be careful. Next, what you're going to do, you're going to start with your north line, okay? And you're just going to go in a clockwise direction until you touch line AB. That particular orange line that I just drew, that is your bearing. If you follow these 3 steps here, you will never go wrong for bearing questions. So take note as well, for bearing questions, there are a few common mistakes that many students will make, especially if you're not careful with this particular topic. So one of the most common mistakes for bearing questions is that if on the very front, okay, if let's say the number is like 2 degrees, or is like 2 digits, okay, then you need to be very careful. You need to write 0 something something. It is a must to write 0 something something, as all bearing numbers are always in 3-digit form. That's number one. Now, number two, okay, you need to remember that for all bearing questions as well, okay, you need to leave your answers in 1 decimal place. Okay, so just nice someone mentioned it, 1 decimal place. So when I say the 3 digits thing, now the 3 digits only refers to the unit side, okay, the numbers, not the decimal places. The decimal places is its own entity. So just remember that, for example, if the angle is like 60.9, so it will be 060.9. This is a very common mistake that many students will make. So please remember, I repeat one more time, all bearing questions always must write in 3 digits and always round your answer to 1 decimal place. Next, we're going to talk about angle of elevation and depression. So for angle of elevation and depression questions, now same thing as the bearing questions, they're always phrased in the same way. All angle of elevations and depression questions are always phrased in the form of something, from something. It's always in this style. They will always tell you where is your point of origin. So what I like to do is to identify where is your point of origin, and then I draw an eyeball. So I have 2 examples that I like to give students. So for example, if you're on the ground, okay, if you're on the ground, okay, and let's say for example, you see a bird in the sky. Okay, so I'm just going to draw a bird. So you see a bird in the sky, and the question asks you to figure out what is the angle of elevation of the bird from you? So what I would do is to first thing draw where is my eyeball. So I have an eye like this. So I'll just locate at the location where I'm interested at. After that, at your eye, I'm going to draw the eye line. So an eye line is basically the line that is passing through your eye that is horizontal, okay, to the ground, parallel to the ground. So for example, it will look like this. Next, I'm going to connect your eyeball to the bird. Okay, that's a very strange sentence to say, but from the eye to the bird, okay, so you're going to connect the line, and now this is your angle. So you need to remember, okay, that whenever you go from your elevation, you go up, okay, that is your angle of elevation. Just remember like keywords like the word elevation, elevator. Yes, I understand the elevator goes up and down, sorry, okay, but just remember, elevate, go up. Okay, that's how to remember. Depression, okay, it's a very sad thing to say, but depression means you're sad, so you're down, you're looking down. It's a very bad example, but no choice. Okay, depression, sad, look down. Okay, so the angle is there. So it's the same logic. Okay, for example, if you're on top of a cliff, okay, I do not know why, maybe you're looking at the scenery, very nice scenery, and all of a sudden on the floor, you see a pile of money. So what you're going to do is you're going to draw the line. Okay, you're going to see where's the money. So I'm going to draw an eyeball right here. Okay, we're going to identify where is the money. So we're going to draw a line from your eyeball to the money. And then you're going to same thing, have an eye line, okay, that is like that, parallel to the ground. So this is your angle. So some people will be wondering, how do you actually figure out what is this theta value? So what we like to do is, or what we can do is that we remember parallel angles. So we have a theta value down here. Okay, these two angles will be alternate because your eye line is always parallel to your ground. Okay, and this theta value down here, you can use tangent theta to always help you solve the question. So I repeat again, depression questions and angle of elevation questions, most of the time we will use tangent theta to solve. Most of the time. I stress again, most of the time, not all the time. Okay, great. That's all for this. Next, let's go into area of the triangle. So this is the concept that you need to remember. The formula for the area of a triangle is half AB sine C. So right now, as you move on, okay, in your arsenal of formulas for triangles, there are a few, okay, which is half times length times breadth, and now half AB sine C. So half AB sine C is literally the same thing as your half times length times breadth. The only difference is that your 90 degrees, sine 90 is just 1. That's why it's not written there. Okay, it's the same thing. Now, half AB sine C is also given to you in your formula sheet. So it's not necessary to memorize. But suggestion from myself, I like to memorize it if your head got enough space. Okay, if your head got enough like memory space, suggestion is to memorize so you don't need to actually flip your booklet lah. So it's just half AB sine C, nothing difficult. The only thing that you need to remember is that the angle must be in between the two lines. I repeat again, the angle must be in between the two lines, or what we call an included angle. Next, we're going to talk about shortest distance. So this is a concept that always comes together with area of a triangle. And I'm very, very certain for it. Whenever schools set question, right, they will always set area of the triangle first, then they will set shortest distance. Most of the time it will be this case. There's a very simple reason why, is because we can use the area of the triangle to actually help you work out what is the shortest distance. And it's given here. The formula is here. So half AB sine C is equals to half times the length times the shortest distance. And you need to remember that the shortest distance is perpendicular. Okay, so this is the concept that you need to remember. Okay, that the shortest distance between a point to the line is always the perpendicular distance, okay, between the point to the line. Okay. What's the reason why? The full explanation is a little bit chim. Okay, but what you can actually do if you are not convinced about it, you can actually just take 3 pencils. Yeah, I'm just going to demo something. Okay, this is something that I used to explain to people. So if you can see my video, what I like to do is you take 2 pencils like this. Okay, you take a line and then you rotate. Okay, So you try to find where is the shortest possible distance, and when you realize it's actually right here, perpendicular. Okay, this will actually help you convince yourself. You don't need the proof, okay, as to why it is 90 degrees, but it actually works. It is always 90 degrees. Okay. There's another way of doing it as well. You can use the right triangle that you have just drawn here, and you can also use your Picasso to actually help you work it out. Okay. Shortest distance will always, sometimes will not be drawn for you. You yourself need to draw. So just take note of that. One more concept that deals with shortest distance that I forgot to put in, okay, into this concept. Let's just write it in for everyone. Greatest angle of elevation or depression. So whenever you have a case in your question that says, find for me the length or the distance from the greatest angle of elevation or the greatest angle of depression, it's always linked to shortest distance. Okay, apologies for not putting this in. Okay, just put this in on your own. Okay. Last concepts for trigo, which will be sine and cosine rule. So for the sine and cosine rule, some things that you need to remember, these two formulas will be given to you in exams, so you don't need to worry if you forget. But same thing, if it's me, I will memorize. For sine rule, it just looks like this. Some people are taught the reverse of the formula, so sine A over A equals to sine B over B equals to sine C over C. But the important thing that you should remember are these concepts here. Which cases give you the rule to help you solve for sine rule? Okay, so for example, if you're given two angles one side, or you're given two sides one angle, this is when you can use your sine rule. Last one is the cosine rule, which is at the bottom. So for cosine rule questions, okay, it's either they give you three sides or they give you two sides and one included angle. Now take note that they must be included. If you don't trust me, you need to see it for yourself. Then you will be convinced as to why it must be the included triangle. So I'm just going to draw a very simple picture here. So if I have a triangle down here, let's call the points. Let's call this A. Okay. A, B, and C. Okay, and I'm going to have A, B, C. So just take note of my letters. Okay, the capital letters and the baby letters, they are always opposites of each other. It's of course on purpose. So you must see carefully that A and B, the angle must be here in order for this C to be calculated. So it must be an included angle in order for it to work. Now, another tip that I like to give students for sine rule and cosine rule is this. Especially for the O-levels or for, prelims or for your Sec 3 exams, this one may be a little bit more difficult, but for the O-levels, it's a guaranteed thing. For O-levels, they will try their best to test every single possible concept. So if you do a question and you realize that you do not know how to do it, and you realize halfway that you haven't used a certain formula yet, maybe it's good to try. Okay. So for example, if the whole entire question, you have already used area, you have used half AB sine C, you have used your sine rule, you have used everything, but you have never used cosine rule at all, and you are down with one last part that you cannot find the answer for, maybe you can try cosine rule. Okay, because their rule is that they will try to test every single concept once. Another tip, and this is a very powerful tip, that works 99% of the time. I stress again, 99% of the time, cosine rule questions are always 3 marks. I repeat again, cosine rule questions are always 3 marks. Why? Because it needs more effort to do cosine rule. Okay, this one is not all the time true. Most of the time in schools is the case. If you do your question and you randomly see one question like, how come got 3 marks? Maybe alarm bell should be ringing in your head that this is a cosine rule question. So I have some questions here. Let me just answer them very quickly. How is the greatest angle of depression or elevation related to the shortest distance? Okay, to answer that question, why is the greatest angle of elevation or depression related to the shortest distance is because of your tangent theta. So the reason is because when you draw your triangle, right, at your shortest distance, that is the only location that can give you the biggest possible angle. So I'm going to assume that you take A math. You can go and study why this works. For tangent theta, when one of your value grows to be as small as possible, the angle will be as big as possible. You can go and analyze the tangent theta, the formula yourself, and then you should be able to convince you why. How to do questions where they ask you to find the shortest distance using angle of elevation but do not provide the area of the triangle? Okay, so for those kind of questions, right, then you do need to. Okay, great. Someone answered the question. Very good. And that is the answer is correct. Very good. Thank you. Okay, so just let's just continue. Okay, let's move on to mensuration. Okay, so the next chapter that I want to touch is mensuration. Now, for this particular chapter, there is a very long chapter from it. Okay, but I'm just going to touch only the important things, which is the two concepts here, which is on arc length, area sector, and segment of course, okay, and radian measure. So the remaining sections of the chapter, which is like volume surface area, that one is in your lower stack. So I never put it in here. Okay. So it's only just one page because the formulas are pretty simple. So first thing, let's talk about a definition of a sector. So a sector is basically just like something that you have learned before, your quadrants. Okay, it's just portions of a circle where you're given a center, you're given a radius, and you're given an angle. So for arc length and area of sector, these are formulas found in your formula sheet. I repeat again now, found in your formula sheet, and all of your angles are in radians. Okay, so anything down there, whenever the question gives you in degrees, you must convert your answer into radians. So for example, let's say for example, if you're given 60 degrees as your angle, you need to convert 60 degrees into radians, and the working is actually below. So this is the formula to memorize as to how to convert between degree to radians or radians into degrees. So it's up to you which one you want to memorize. Personally, I'll use the first one. Okay, for example, if it's 60 degrees, so just take 60 over 360 times 2 pi. You will get your answer. Answer should be pi over 3. So you can just go and practice doing other angles, like for example, 45, 75. Okay, just make sure that you're able to convert them into degrees and radians. So a little suggestion or a little tip that I like to give students for this chapter is that schools like to put the sector questions and also the trigo questions together. Trigos in EMAth are always done in degrees, while the sector questions are always done in radians. So one thing I like to do is I like to go into the exam with two calculators. One calculator specific to degrees, one calculator specific to radians. So if you like that, right, then you know that you never need to convert between the two. Okay. Someone asked what happens if they ask you for in terms of pi. I so far haven't seen any EMAth questions that ask you to leave your answers in terms of pi. I don't think there are such questions. Yeah, all trigo questions will for EMAth specifically, it will be in degrees. 180. Okay, so for the 180 over pi one, for me, okay, this is the official formula. Of course, when I teach my students, I teach actually theta over 180 times pi. It's the same thing. It's just that they want to tell you about the 360 degrees and the 2 pi. It's literally the same thing. Okay. What's the difference between the radian function in the calculator and the degree function? So it's basically whatever we're doing here. The values that you calculate will be different. So when you calculate an angle in the degree function of your calculator, the angles will be in terms of degree mode. But when you're in the radian mode of your calculator, that's when your answers will be in terms of pi. So you will see answers like between your numbers will be very small. Okay, so just be careful about that. Okay. How do you know when to use radians? So the rule of thumb for this chapter is we always use radians for sector questions. Okay, so there is never a case where we never use radians. Okay. I don't understand why degree to radian give you that formula. Okay, the very simple reason is this. Is because, okay, I don't want to go too much into detail on this, but pi equals to 180. So you're just basically finding the ratio, okay, the ratio that gives you in terms of pi. So I give you a very simple example. Just now I use 60, right? So for my 60 degrees, I'm just going to find out how much of pi is 60 degrees. So if I know that 1 pi or pi gives me 180, Okay, and I know that 180 divided by 3 gives me 60. So 1/3 of pi will give me that. And this calculation here will actually help you to compute it. There's another formula, which is theta over 180 times pi. This one works as well. So it's up to you which one you want to use. Personally, I use the one on the right. Okay, I don't really use the one there, but I just want to follow the textbook. Okay. Can I just use 60 over, I got 60 over 2 pi. Okay, there are different ways schools teach this particular concept. So I suggest you just follow whatever you know. I don't want to confuse you in case it's something different here. Okay, so just remember that this chapter is in radians. Okay, do not confuse yourself. Do give a try on some of these questions here. They are not the easiest things in the world, so just try. Okay, just take note. Okay, I'm just going to move on. I think I have 2 more questions, then I will answer. The formula must use 2 pi since 360 is 2 pi. Yeah, you must just follow the formula. So the formula says theta over 360 times 2 pi. You're basically just finding how much of pi is something. It's just like, for example, if you're finding a percentage of something, it's the same thing. For example, if you have 50 liters out of 100 liters, and you're finding the percentage, the calculations will be 50 over 100 times 100%. It's the same logic. How can we convert radians to degrees and degrees to radians if they give us the length? Oh, that's a very odd question. If they give you the length, sorry, I don't really understand your question. I think they need to give you more information. Cannot be they just give you the length. Yeah, not possible. Okay, last chapter. So, which is coordinate job. So this is another chapter that I know some students struggle pretty heavily with. So I hope that through this session, you'll get better at this topic. This topic is not the most difficult thing in the world. So let's just go through. So first thing, equations of a straight line. So for an equation of a straight line, okay, you need to remember that it's of the form y equals to mx plus c. So for y equals to mx plus c, you need to remember that m is your gradient and r is your y-intercept. So one very, very common mistake that many students make, especially in either EMAF or AMAF for this chapter, is that the coefficient of y must be 1. If the coefficient of y is not 1, then you're going to have a very big problem. Okay, you need to make sure that you divide the whatever value is there down such that you make the coefficient of y 1, so that you can read off your gradient and your y-intercept respectively. Next, gradients of a straight line. So there are 4 different types of straight lines that we all need to know, going up, going down, horizontal, and vertical. So for lines that are going up, you need to remember that your gradient is always greater than 0. Okay, the one going down, okay, is your gradient less than 0. For horizontal lines, okay, is your gradient equals to 0. And for vertical lines is when your gradient is undefined. So just take note of this. This is what you need to know. Next, we're going to talk about the distance between 2 points. So distance between 2 points is just given by a simple formula, x2 minus x1 squared plus y2 minus y1 squared. Now, just take note that I'm using x2, y2 and x1, y1. These are very important that you label them correctly. You cannot interchange the coordinates as you will get it wrong. You need to make sure that if you're choosing x2, the number beside the x2 must be your y2. It cannot be anything else. And you have a square root because you're looking for the length. Essentially, you're finding Pythagoras theorem. So in exams, if let's say you're very desperate and you forgot the formula, you can just use Pythagoras theorem, you get your answer out. Next is the conditions for parallel lines. So this is a very important concept as well, as this is something that always appears in this chapter that many students never spot. When the question says that 2 lines are parallel, it means that the gradients are the same. However, you need to be a bit careful about something. Whenever you say that 2 lines have the same gradient, there is one more condition for parallel lines, which is that the y-intercept must be different. So this particular point here, this is very important. And I believe a lot of schools actually do not stress this fact. So I want to stress this with a lot of importance, as in order for a line to be indeed parallel, you need to make sure that the y-intercepts are different. Because if you're going to have a case where two lines have the same gradient, but the y-intercept values are the same, then you're going to have a very big problem because your line is on top of the other line. And then you'll not be able to say that these two lines are parallel. So at the bottom down here, there are three possible cases that I think are very important. What happens when the gradient and the y-intercept is the same? What happens when the gradient is the same and the y-intercept is different? And what happens when the gradient and the y-intercepts are different? So these are three important points that you need to remember. So just take note of that. Next, I'm coming to the end already. So now I'm just going to stress some of the important things that you need to remember whenever you're doing this chapter. So number one, let's talk about collinearity. So collinearity is something that as of right now, for Sec 3s, you will not see this word very common, but when you take vectors in Sec 4, this is a very common word that you will see. So the definition of the word collinear means that 3 points lie on the same line, or points lie on a straight line. How do you prove that 3 points lie on a straight line? So this is a very important concept that people need to remember. You cannot anyhow assume that any 3 points on a line is considered straight, unless the question says so. This is the reason why questions will always say, oh, ABC is a straight line, because they must 100% define it to you. You cannot assume that any 3 points on a straight line is indeed straight. There are, of course, exceptions lah. So an exception will be if your line is part of a figure. If it's part of a triangle, then obviously it's going to be a straight line. Or whenever the question says it is straight. If the question never say, then you need to be extra careful. Okay, please go and clarify. If in case in exams it's not stated, do ask your teachers. Okay, if there's something wrong with the question. Now there's a way to test for collinearity. Okay, and the way to test for collinearity is we test for same gradient. So if the lines have the same gradients, then obviously they are going to be lying on the same line. But there is one more important condition: the existence of a common point. I need to stress the importance of this because you can just very simply say that two lines have the same gradient. But remember the concept: two lines of the same gradient means that they are parallel. It doesn't mean that they are collinear. In order to justify that they are collinear, there must be a common point in order for the whole entire line, all 3 points, to lie on it. Now, someone asked what happens if it's 2 points. Now, just think about it. When you have 2 points and you draw a line between your 2 points, it's 100% straight. There's no test. Okay. So let me just re-explain the common point one more time. So for example, C. Okay, so you need to look at this line. AC is 1 point, and like that. This must be a common point of the line. Then you calculate your gradient of AC, you calculate your gradient of BC, and this will tell you that all 3 points lie on the same line. Because remember, it is possible that when you have like parallel lines, then two lines same gradient, but it doesn't mean that they're collinear. So you must share a common point in the center or somewhere else, okay, such that it is common within the line, common within your gradients, therefore it is collinear. Next, nature for coordinates of horizontal and vertical points. For the common point, not 100% needs to be in the middle. Sometimes it can be at the side as well. So let me just see. For example, if you calculate the gradient of AC, the one in purple, I hope you can see. Okay, maybe let's use orange. You calculate the gradient of AC, and now you calculate the gradient of AB. And there's a common point of A. So this will tell you that these two lines, okay, they start from the same origin point, and they have the same gradient. So obviously, they're all going to lie on the same line. Is it possible to be more than 3 points? Yes. Just use the same concept. Just prove all the way. Just prove that the gradients at every single intersection is the same. Okay. I'm going to move on. So the nature of coordinates of a vertical line and a horizontal line. So you need to remember that for a vertical line, the x coordinates are the same throughout. And for a horizontal line, the y coordinates are the same throughout. So for example, if the question says that, for example, this line is parallel to the y-axis, this will tell you that the line is vertical, and therefore the y coordinates or the x coordinates are the same. If the question says that the line is horizontal, then of course, all the y coordinates are the same. Next, solutions to two linear simultaneous equations. So this is a very important fact. In case you didn't know, whenever you are doing simultaneous equation questions, you are literally finding the points of intersection. So this is a tip that I stress to students. Whenever they see the keywords points of intersection, it should jump out to you that this is a simultaneous equation question. And I hope you guys don't get the question wrong. Whenever the question asks for the solutions, please write them in a coordinate form. Next, coordinates on the x and y axis. So if the question tells you that if your line passes through the x and y axis and your job is to figure out the coordinates, just need to remember that on the x-axis, y equals to 0. And on the y-axis, x equals to 0. And you have your respective coordinates. This one is very easy to make careless mistakes, so be careful. Last one, steepness of a line, or second last one, sorry, steepness of a line. So sometimes questions will ask you to predict what is the gradient of a line, or they will give you different shapes, different lines, and they will ask you which of the following should be of this gradient, of this gradient, of this gradient. You must know this very important property. The bigger the numerical value, the steeper the gradient. The smaller the numerical value, the shallower the gradient. Take note that this diagram down here and whatever I just said is strictly for positive gradient. For the negative gradient side, it's a little bit different. For the negative gradients, actually, the bigger the number or the smaller the number, the steeper the line, the smaller the number means, like, for example, negative 40 compared to negative half. Negative 40 is going to be a lot more steeper compared to negative half. So just take note of that. Okay. Yes, only gradient affects the steepness of the line. It doesn't affect the length. Yeah, thank you for the question. Okay. Last one at the bottom, okay, and this is the very end, okay, which is the units for coordinate jump questions. So just remember that for all coordinate jump questions, we always write in terms of the words units and units square. Okay, it's not cm and cm square, unless the question says so, which is very, very rare. We always state, for example, if the question asks you to figure out the area, then we're going to use units square. Last thing, this is more for A-math people. Now, if you know your A-math, there are 3 more concepts within this chapter that are not in the E-math syllabus, namely the alternate equation for straight line, the shoelace method, and the midpoint. These 3 are strictly for A-math. So you cannot use these in your question. So I have seen people where they calculate areas for E-math, they use shoelace, and that is wrong. Okay, you're not allowed to do that unless your school says so, then sure, follow what your school says. But from what I know, it is not acceptable. So just use E-math convention. E-math do E-math, A-math do A-math. And we are done. So everything else here are just all example questions. So I'll just leave it to you to do it on your own. Okay, I'll just answer questions for the next 2 minutes. Then I'll go back into whatever I want to see. Okay, where can I get this revision package? Okay, wait. I resend the link again. Okay. When do we leave answers in mixed number or improper fractions or for all types of questions? Rule of thumb, mixed fraction. Why doesn't the hypotenuse of a triangle in quadrant, example second quadrant or fourth quadrant, not have a negative value although it is a negative gradient? Wow, that's a very interesting question. Okay, for that question there, that is an A-math question. Yeah, I don't think I should answer it here. Sorry. For the person that just asked me number patterns, okay, then I'll wait first. Okay, if number patterns must wait a while. Yeah, to the person that just asked that, no, cannot. By right, cannot, because you need to explain how you get that from. Wait. So for negative graphs, the bigger the value, the steeper it is. Okay, the bigger the value must be careful. So it's the bigger the number, but because when you put a minus sign, like for example, minus 40 to minus 10, minus 40 is smaller. So just be a bit careful. Okay. Then how do we find area without using shoelace? So for those kind of questions, it will be very obvious. You just need to see with your axis, you will be like triangle. Yeah, it's very obvious. How do I get the answers for all the answers for the supplementary questions? Okay, I repeat again. The answers for the supplementary questions will be provided 1 week later okay, and it will be found within the Dropbox folder. I'm going to show you where that folder is in a while, okay, because a lot of people are asking. Yeah, okay, I saw the question just now, so sorry about that. If you want to convert degrees into radians, but we want the circumference, we times 2 pi r, and if we want, for Nerissa, right, your question, can you PM it to me? Because I don't understand. Yeah, I don't think this question you can ask now because it's a little bit complicated. Yeah. Okay, there are people asking for mode, mean, median, vectors, what else have I seen? Number patterns and probability. Okay, wait first because I don't have time. Okay, so wait first. Wait first. Okay. So yeah, that's basically it. Okay, I've covered everything that I wanted to say. Basically, everything is here. Now, just want to go back into my slides. Okay, so for those that are asking for other stuff, now wait first. Let's settle the whole section first. Okay, so I go back into my slides. So now I want to settle all of the housekeeping materials first. Okay, there are a few things that I want to say. So for those with questions, wait first. I'll let you ask your questions later. Okay, so let me settle this first. Okay, so yeah, I want to do a short little giveaway. So for the remaining people that are here, so if you want to win a copy of my eMath curated notes, just hold up for a while. Okay, now the Dropbox only has Sec 3. Okay, so I will not be giving Sec 4. If you want Sec 4, then you need to look for me personally. Yeah, and then of course need to pay lah. Okay, so this one is free, it's mainly only for Sec 3 topics. Okay, so right now, I want to do a little giveaway, and I do want to share some important stuff as well. Okay, for the Sec 3s that are still here. Okay, so like I said in the very start, okay, I will not be doing Kahoot because number one, I don't like Kahoot. Okay, so I will be doing it in another style. So it's like this. So I will actually be showing one question on the next slide after this. It will be medium difficulty. I won't tell you where the question is from because like that you can Google the question. Okay, basically it's very simple. You just need to send the correct answer, okay, the final numerical answer into the chat. Okay? And if let's say I don't trust your working, then you cannot PM me. You need to just message to everyone so I can see. And it's the very, very first person. As long as I see the number is correct, then I give it to you. Okay, and whoever gets it, you will get the curator notes for free. Okay, so just take note of that. So I repeat a few things. Number one, I don't really need you to show working. Okay, but if I feel that you didn't get it in a very legit way, I may ask you to give me a proof lah. Okay, so just take note of that. Okay, so my suggestion is to write working because you cannot just bomb an answer without knowing the reason why. For this upcoming question as well, the question is a little bit difficult. So the solution for this question, I will also put it in the supplementary questions, the solutions. Okay, so I'm going to review the question in a while. Wait, let me find my answer first. Okay. Not this one. Okay, I have also prepared like a bonus, just an additional question in case this is a little bit too difficult. Okay, so I'm going to show the question. You have about 5 minutes to try. Okay, then if you can get it, just PM straight into the chat so I know. Then after that, everyone can stop ready. Okay, so I'm going to show the question. So all the best. It's a very simple question. Okay, ready? 3, 2, 1, go. So I'm going to read the question to you, okay, in case it's a little bit blur. So you have a circle C1 that is inscribed within an equilateral triangle, as shown in the diagram on the left. Next, you have a second circle C2, and this circle is tangential to the circle C1 and to the two sides of the triangle. You have a third circle C3, and this is tangential to C2 and also to the two sides of the triangle. I need you to give me the ratio of the radius of the circle C3 to the radius of the circle C1. The answer is the numerical value. Okay, so you need to give it to me. Okay, I won't comment until someone gives me the correct answer. Okay. Well, okay, I got it. Someone got it. That was fast. Okay, wait, someone got it. Okay, wait. Okay, that was surprisingly fast. Chloe Low. Can you PM me your solution? Yeah, okay, wait, we can stop already. Yeah, because someone got it. Okay, for Chloe, right, can you tell me? Yeah, then I send you the notes. Okay, done. Thank you. That was fast. I expected it to be longer. Okay, wait. Can you tally me? Then I want to check. Yeah, okay. The answer is 1:9. Okay, so the answer is 1:9. The solution I will just release it another time. Okay, yeah, thank you. Okay, so yeah, 1/12, 1/3 is all wrong. I just dropped my Telegram. So you just search for me on Telegram, then you PM me. I want to see your solutions, how you got the answer so fast. And then also you can send me your address, then I send you the notes. Okay, thank you. So for the rest, yeah, sorry, it's very fast. Okay, so thank you for trying. Yes, the answer is 1:9. I will drop the solutions another time. Okay, but good job. Okay, so this one never mind. Okay, so right now what I want to do is just to go through this last part and then I will answer some questions lah. Okay, so this is a very important quote that I shared. Okay, so even though you understand every single thing in the syllabus, you do need to make sure that you'll be able to apply your concepts and everything. Okay, so very important thing is that practice makes perfect lah. So this set of notes is not everything in the syllabus. So it's just the important things that you need to know. So just take note that you do need to practice as well. That's why I always provide questions. And to the best of my abilities, I try to provide as many questions as possible. Oh, Rakesh, you're here. Hello. So I got some revision tips for everyone. So number one is to really practice. So math is a subject where you do need to practice. Without practice, right, confirm go exams for GG one. So even for me personally, when I do my uni stuff, I do have to practice as well. So just take note of that. Okay, so please practice as much as you can. Okay, and also make sure that you have the resources lah. Okay, that can give you all this practice, all the questions and everything. Next is to clarify your doubts early and get your foundation secure. So what I need is that I really need everyone, okay, to go and figure out all the things that you do not know. Go and ask your teachers. You can ask me. Okay, you can ask anyone that is out there to help you for math. Okay. Next is consistency is key. So suggestion is that, okay, for me, I'm a little bit more extreme, of course. Okay, so for me, myself, I do math literally every day. So for me, I partition my time in a way where I focus 1 hour on math every day. So 1 hour on E, 1 hour on A. Then I do it in a very consistent pace. So when you go for exams, you don't need to go for a mad rush before your final paper. And everyone here takes multiple subjects. When I was in O's, I took 10 subjects. So I need time to study for all my 10. So this is how I do it. I partition my time well. I tell myself, okay, when I reach home, I need to take 1 hour of 1 hour to do math, 1 hour to do chem, 1 hour to do physics, 1 hour to do bio. Okay, then I got my piano, violin. I need to settle those as well. Okay, partition your time well and make sure you do it every day so that you don't forget things. Okay. Subject combi triple science. I took triple science and I took music and higher music for O's. Yeah. Okay, so I want to talk about this. So wait, those questions about me now I'll answer later. Okay, so I want to talk about this. So this is pretty important. Okay. Okay, wait. Okay, so I want to talk about this as well. Okay, so number one, I want to advertise this group tuition and also my classes that are ongoing next year. So number one is I want to talk about the different types of promotions that are ongoing. So there's 3 down here that I want to stress. So the first one is an early bird promotion, and I believe all the subjects are doing it as well. So early bird means that you guarantee 1 minute to teach you next year. And later after these slides, I'm going to show you like the advantages of what you will get other than all these listed here as well. Some things that I do personally for my own students. So you will get a free set of the curated notes and you get 3 subjects, not just my own subject. You will get other subjects that you wish. You get to choose like the time slots that you're actually interested in to come for classes. Okay, so that one you have priority in it. And you also get this exam revision, this exam kit. So what is this exam kit? So I'm going to show you a little sneak peek of what this exam kit is. It's basically the same. It's the notes again. It's another set of notes, but this set of notes is more stuff. So it has a lot of things inside. I'm going to show you very, very quickly. It's here. So yeah, this is actually the EOY package that I prepared. It's, I forgot how many pages, 100, 130 something, I think. Oh no, 100 plus. Okay, so for example, when you see, when you get this package, right, what you will get is actually more chapters, okay, and you will also get access to also the summaries, the answers, and each chapter also has a lot of questions. So the chapters will include whatever you have seen just now, and each chapter is more filled out with more stuff, okay, and also the opening 2 chapters that are also from the syllabus. So this is what you will get from this exam kit if you were to choose to go for that early bird thing. Next thing is also the trial package. So this trial package is, let's say, for example, if you're a little bit unsure of whether you like my teaching style, then you can go for this. It's a trial class, and this trial class will be completely free. So at the very start of the year, at the start of November, December period, I'll be opening up trial classes for everyone. So if you're interested to join the trial class, then you can earn 2 sets of the notes, okay, and you get to choose your time slots also that you're interested in. Now, take note that there's a timing for it. So for the early bird one, it's until 30th September. And trust me, there are limited slots because there are people already looking for me to teach. And I do have current students this year. So those will take priority and everything. Okay. There's a trial package as well, and that is until the 31st of October. But take note that if you want the exam kit, you must go for the early bird one. Okay. So later at the very end of the slides, there will be a link for you to sign up if you're interested in doing a trial lesson with me, or if you're interested in going for the early bird. So if let's say you really do sign up for the early bird, I will PM you personally the exam kit, and also keep this to yourself as this is only specifically for you. Okay. Now, I want to share also the resources that I give my students. And if my students are in here, you should know that these are the things that I do for you guys. Okay, I go all out for resources and everything. And this is something that I pride myself upon compared to other tutors out there. So there are many math tutors in Singapore, but how do I differentiate from them? It's my database of stuff. So I have a lot of materials that I want to give students. So every single chapter will have notes. And this is an example of the quality of notes that you will see for the lecture notes. But of course, there will be more stuff, more things that you need to take note of, worked examples, and also many, many questions that you will get access of. Okay. You will get homework as well. So every week I provide a copy of homework. Now this homework is very unique because I don't photocopy from assessment book or what lah. All questions will be from prelims, and all questions will be from what school like to set. And I will cover every single topic every single week. Okay. I have been keeping resources since like 2008. It's very, very old stuff, and they are very applicable stuff right now. So I'll use it to form my homework for you guys, and I'll go through it during class. Next, class assessment. So this is something that I do with my students to help them work with exam conditions. Now, how is this? Sometimes people are very, very good in exam conditions is because of things like this, enough practice. So I'll ask them to stay back, not stay back, but like basically stay during class, 15 minutes. Okay, then you will be able to go through these questions and everything. Okay. Class tests. So something that I do as well is to host class tests. I'll set papers. In the Telegram channel, there is also like mock papers that I set for my students that they all set for, about 50 plus, 60 plus students set for it. Okay, then I will mass go through. It's just like school. Okay, it's just that I do it on a bigger level here. Okay, so this is something that I do as well, and everyone will get feedback from their work, and I also make sure that they will improve as much as they can. Solutions. Okay, so this is something that this is a personal thing for me that I know a lot of people don't do it. So I provide full answer key. And these answer keys are not just like screenshot off the school paper, that kind of thing. No, I handwrite myself. So everything is full-fledged with workings, with solutions, and everything that you need to know. As samples, you can just look at all of my monthly questions. It's about that level. I will even dare to say that my homework answers are even more detailed. Okay, and I spent a lot of time on it. So the supplementary questions will be going through that as well. That's why I do need a bit of time to work on them. And by the end of next week, then you will get an access to it. Okay, and then also for my own students, you will get the curated notes for free. So it's the notes that I wrote, weekly homework, revision packages, and school papers and everything. So something that I like to say as well is that for my students, I think everyone says the same thing. It is impossible that you go under me and you don't have enough stuff to do. Okay, because I will always try my best to flood you with as many things as possible so that you have enough practice and you have enough questions to do. Okay, my goal is to make sure that you have so many until you don't have enough time to finish. And I succeed all the time. So you can try, if you are actually finishing the work that I give, means that you're not focusing on your other subjects. Okay, so just take note of that lah. Okay, and I also go through O-level papers, which is what I'm doing with my current graduating batches. Okay, so I just want to promote my other sessions as well. So I have an A-Math session that is going on tomorrow from 7 p.m. to 9 p.m., exactly the same style. I'll be covering all the topics that I've already released. So if anyone is interested, you can look for me. Last one is H2. So someone just asked me, why is it that I previously don't take H2? A very simple reason is because of time. So as I'm graduating this year, my time has freed up. And I want to dip my toes into A-levels. I love the A-level syllabus. I think it's a very, very fun subject. I love H2 math. So that's why I'm planning to teach H2 math next year. So if you're interested, you can look for me. Okay, same thing. This A-math revision is all for Sec 3s. Okay, it's mainly for Sec 3s. But of course, I'm covering the difficult topics as well. So if you're Sec 4, feel free to join. Okay, so this is the last slide. Okay, this is the slide to actually help you to sign up for the early bird or for the trial package. So do consider which one you're interested in. Do remember that there are limited slots as well. So if you really, really want to work with me, okay, and trust me, I want to work with as many people as possible. Okay, I really do want to help you guys get with your get well with your A-math or E-math or whatsoever. Okay, do sign up for either the free trial lesson or you can sign up with me as a student. Okay, remember that if you do sign up for the early bird, you do get access to the revision kits as well, which I will send out as soon as I can. No, there's no Kahoot. Yeah, I already finished the giveaway. Okay, so I'm going to stop the recording here. So for those online, thank you very much. Hope you enjoyed the session. Okay, and now I'll just answer questions. Okay, goodbye.